Hi everyone. Uh, Welcome to another session of Hangout from Digital CRM. I'm Raja Mitra, I'm one of the co-founders of Digital CRM. And we have a very interesting and exciting session today with Dr. Abhijit Sanyal. To give you a brief introduction, the topic he's going to be talking about analytics and more specifically predictive analytics and big data. And he's going to be talking about several case studies in several domains to illustrate, the applicability and how it was done and what were the spin-offs and benefits and so on. Now, to briefly introduce Abhijit, you can look up his detailed profile, which is there. But to briefly introduce him, he's got an electrical engineer from IIT. He's got an MBA, and then he went on to do a DBA, a PhD in marketing and quantitative research. And he's got loads of experience in the areas of marketing strategy, analytics, um, quantitative research, and so on. He's worked for Wyman, Mercer Consulting. He's worked as the analytics head for certain boutique companies, and he has, I think, in terms of experience in these arena, in predictive analytics and so on, he has got, the number of cases he has handled in his career is very, very extensive. So, saying that, I'll leave Abhijit to fill in any blanks or any aspects which I may not have touched on, and I will hand you over to Abhijit to take you on from here. He's got a presentation, and he's going to be describing in brief the field of big data and analytics and predictive analytics, and then he's going to lead you through several case studies. And at the end of each case study, you could ask any questions. And this message is also to those who may be viewing. You can use the Q&A app to ask questions. You can join in the room. We have space in the room. You can join in and ask questions, and you can participate in the process. So at the end of each case study, we will take questions on that particular case study, and then we will move on to the next case study. So saying which, it's over to you, Abhijit.
Thank you, Raja, for the introduction and for the all the other elements that have made this event happen. So what we will start is, as Raja was saying, talk about predictive analytics and some cases along with that. So let me share my screen here so that you guys can. So what you're seeing now is the predictive analytics, the content of what we're going to talk about today, and can everybody see the screen? At least the next slide.
Yeah, it's clear.
I want to make sure that there's a reality check. So the content for today is basically about big data, the sources, the taxonomy, a brief introduction to predictive analytics, and then 3 cases. The first case talks about employee and customer satisfaction. How can you link them? The second case talks about churn in the telecom industries, and the third case is about preventative maintenance and monitoring and predictive analytics around that. So what are the sources of big data, and why are we in this particular arena right now? What's the idea of big data, and how has it been happening over the last few years? So big data is kind of in the news for the last 5 to 10 years, and a lot of it is basically as a result of what I would user-generated and consumer-generated data sources. So having said that, let's talk a little bit about what the user and consumer-generated data sources are. So user and consumer-generated data sources essentially talk about, when we do Facebook, Twitter, say you put in a survey, you transact using a credit card, all those are essentially user-generated data sources. So And then you have the machine-generated data sources. So these are basically very broadly what I would call as basic sources of data. So you have, user-generated, consumer, or machine or asset-generated. Now, when you look at machine asset-generated data sources, you have things like, factory assets, transportation, like whenever you buy a ticket, or whenever, say, an aircraft takes off, all the data from the, say, the 4 engines, Rolls-Royce engines on the Airbus, essentially start transmitting data. To the extent that if you take an elevator in a high-rise building, there is data being generated as to what's the load on that elevator, which floor does it stop, what are the other issues, what's the time of day, that if there are any failures on the elevator, etc., etc. All the data is being generated. Then there's obviously the Internet of Things. There is operational data, there are sensors and robotics, there is partner data, closed-loop data, so forth and so on. So what is happening as this whole user or consumer-generated data is being generated, as well as the machine or asset. These are all enabled by inexpensive microprocessors. There is also, sensing capability at the same time. These sensors are connected, and these sources are generating enormous volumes of data. Think in terms of, I think, petabytes, exabytes, etc. And the cost of collecting, generating, processing, and storing all this information is becoming cheaper every day. So you have data in the cloud, low storage costs, internet and connectivity. Essentially is becoming a utility. And what happens is, as this basically results in huge volumes of data being generated, and that's what's happening right now in this entire space, with the result that there are many companies, organizations, etc., who can't even figure out at this stage what to do with all this volume of data. So let's see. Let me take you to the next slide. So what happens is, as you can see that with the sorry, just give me a minute here while I figure this out. Right. So what's a big data taxonomy? Big data is more than mere volume, right? So pre-big data, you had these traditional data sources, survey, transactional, high acquisition costs, storage and analysis costs. There were sample size constraints. And what's happening right now, you have data variations. You have the volume of data, huge volumes. Then there is velocity of the data, which means that data in motion, there's variety, data in many forms, structured, unstructured, text, and then there is veracity. A lot of this data has missing data that's incomplete. There are ambiguities, there are latencies, there is deception, all kinds of issues around. So most companies have to. I mean, this is a kind of an easy way to kind of understand the 4 V's: the volume, velocity, variety, and veracity of what's happening with big data. And a lot of people talk about the 4 V's. And so if you come across this particular term, you realize that this is what most people are talking about. Oh, okay. So now I can use my page down key, which was causing a source of confusion. So anyway, so what is predictive analytics? I think these are the slides we've seen before in a previous presentation. So it's a smart use of a variety of these data sources that we talked about, use statistical modeling and algorithms, and to provide insight into operational, tactical, and strategic decision making. It is evidence-based, is proactive, and dynamic. So typically what is happening in the early stages of most of this data analysis, etc., was we were reporting, then we say what actions are needed now, so it's reporting, alerts, and monitoring, and then we say why is this happening, analysis, what will happen, which means what will happen in the future, what's the best that can happen, how can we influence the best to happen, that is optimization. So the next slide talks of this reporting and analytics versus predictive analytics, and you can see that there's a certain amount of analytics mature as you go from the left to the right, from simple to complex, right? It's essentially the same idea that was there in the previous slide, but now we're trying to understand it at least in a sequential or a time-based fashion. So this is another slide which we've seen before, and just to get a sense of, so you have data which is structured, unstructured data, another flavor of saying the same thing as we talked about in terms of the volume and the veracity and the variety of data. Then we have predictive analytics, which there are very broadly two categories. Either you estimate certain quantities, or you classify a specific unit of analysis into various categories. And then you have machine learning. Machine learning and predictive analytics I kind of go hand in hand. They are the two sides of the same coin. So you have supervised learning where you know your right answer, so your dependent measure is available, and then you want to find out what predicts that right answer, what predicts sales, what predicts, say, machine failures, what predicts churn, etc. And then you have unsupervised learning, which is essentially you want to discover structure in the data. You have lots of data, but you want to find out which segments of consumers are essentially think and go and act and behave together. So you want to discover structure in the data, and there is no real answer out there, but it still requires to do some kind of data analysis. And unsupervised learning is somewhat allied with classification, but that's not always true. Let's take one case. This is a case happened many, many years ago. So this is why I call this case pre-big data, but it's also data. And what we were trying to do out here was to link employee and customer satisfaction. The mandate for this case came from HR, which was essentially trying to basically make some major investments, and the chief sponsor was the CEO of this major bank based out of Boston here. And they wanted to basically find out that there was a link between, say, employee and customer satisfaction. So the hypothesis was that if there is employee commitment, then that results in overall customer satisfaction, and that's a virtuous cycle, essentially resulting in greater and greater levels of satisfaction, commitment, and therefore profits and revenues and ability to compete effectively in the marketplace. So what we did was we collected employee data across the entire bank. We collected then customer satisfaction data, and obviously there was a challenge because one of the things that happens typically in predictive analytics is you need to understand what is the unit of analysis? What unit are you analyzing? So in this case, we had employees at one level, then we had, say, customers at the other level. So essentially, it's very hard to do that linkage. But what we did was we had a very hard model, which means we had what they call a structural equation modeling, trying to derive employee commitment. And then we used some very soft linkages. I call these soft linkages because it's not a one-to-one match for an employee to a customer. And then we did some soft linkages to try to estimate how customer satisfaction at the branch level was linked to, say, how employee commitment at the branch level was linked to customer satisfaction, and therefore higher levels of revenue and profitability for each branch. So just think of it this way: as there are 20,000 employees, and then there are maybe 1 million customers across 1,000 branches, and how do you essentially link all these things together? It was fairly successful. The project was, it went up to the board level of this particular bank. We were able to demonstrate the specific link, and by and large, these essentially became a major input into the HR investments for the bank. The next case is a little bit more detailed. It's detailed at the level of, say, at the individual customer level, and this is called churn modeling. So this is a leading company in the US, a national footprint, and there were various phases. I'm only talking about the first phase of this particular effort. So how do you predict customer churn? And the reason why I'm going into a little bit of detail out here is these things. One of the challenges that I've had is how do you make complex things simple, and I think that's one of the hardest thing to do. To understand a complex thing is difficult, but even trying to make a complex thing simple is even harder. So what I'm going in is a little bit of detail, because when you start talking of churn, you have to divide the entire customer life cycle into various portions, because each customer will have different volumes of data or different extent of data in their database depending on how long they've been. So this particular model essentially assumes that, or restricts the modeling to customers who had 3 months of tenure. So the churn was based on, say, 6 months of data from, say, the time of the snapshot taken, that is T1 plus 6 months. There were various kind of input variables. They were static in the sense that they were usage-related, behavioral and demographic variables. And the various kinds of model, a month one model to identify and score churn in the early life cycle. The month 3 model was to identify score customers that are greater than 3 months of tenure. So this is again another detailed slide. As you can see, it's a lot of stuff out here. But let me try to take you very briefly. So you see the red line in the middle. It's a snapshot of users taken on, say, May 1, 2005, which is just a year. That was when the snapshot of data was taken of all the variables, all the static variables as such. And then we observed it for the next 6 months. Going forward, how many customers churned. So you actually had to take another data snapshot 6 months after that red line. So for example, a customer A, say, activation date on the left-hand side, and then they went on, it was a continually active customer, which means that even that 6-month period of that we observed the customer, they were active. Customer B came in, before before the 3 months period. They had 3 months qualification, but they churned after 5 months. So we were saying that, okay, activation, then you must do some top up with a minimum of $20 call, and then you become past, what the term was, past current, which means it was 60 days, and then you churned at the 151st day after activation. So, and then this is another very busy slide, but just let me take you very briefly through it. What we did was the nitty-gritty statistical aspect was a backward stepwise logistic regression, and the dependent variable was whether you churned or not. There were very static variables like cohort, age, retailer, handset usage patterns, payment information, voicemail usage, etc. I mean, the key thing to kind of focus on is that results of the distribution of churn propensity and the gains chart methodology. And the basic idea is, why do we do all this? Why do this company spend nearly, at least $500,000 or more to kind of do this? The basic idea is to get that red line, or in the gains chart, get that blue line, which is a curved blue line. And the basic idea is that if you've identified people with a churn propensity score, then it is a very much more efficient way. Because if you want to start doing various kinds of marketing activities, like send a free offer, then you have to send it to everybody in your customer base. Now you can only send it to a very focused group of individuals. So essentially, even your mailing costs and etc. are reduced significantly. So for example, the churn propensity score, that if you see the red line marked by an A, that's a distribution of churn propensity predicted by the model. The black line is what if you had, if essentially is the mean churn, which means the absence of a model, that's what you do. Let me take you to an example which talks about the application. This is again a very detailed one, but basic idea out here is, in absence of the churn propensity model, this particular company would have to spend, say, $5.5 million just to kind of reach the at-risk group of subscribers. So with the churn propensity model, you would have to spend nearly half of that amount, because you could target and identify who the at-risk group of consumers was. So the basic idea is, this example essentially says that the reduced cost of targeting a given percentage of at-risk churners with an offer is reduced significantly when you have a churn propensity model going. The next slide also talks about the another application where if the customers are essentially given two identification. One is what's their, this particular project, I can also tell you that this was just one phase. There were multiple phases of this where we had to do a 6-month greater than model. We also developed a subsequent, say, customer lifetime valuation model as such. So if you take a customer has a certain customer lifetime value and has a certain churn propensity, so with these two elements, essentially you can put each and every customer in this particular matrix. So let's say the new customers are 6% of the base, and that what we are doing is, okay, with those guys we'll basically do a particular strategy called early engagement. And let's say the highest spending customers who are 8% of the base and they contribute 40% of the revenue, which is typical, right? So and that's a Pareto rule. We'll come up with loyalty and recognition programs. So this allowed the company to basically, rather than doing one-size-fits-all kind of strategies, basically divide the customer pool and essentially come up with continuous programs that were targeted for a very specific combination of customer value and churn propensities. Any questions? I mean, I think we can stop now for a few minutes, or I can carry on.
Abhijit, I think I'm sure there are questions on the first two cases that you covered, and
Right.
because these are fairly extensive cases, and I'm sure predictive analytics is not exactly a very easy area. So before the questions start, let me very quickly introduce you and the audience to David, who came in specifically, for this because David, I mean, as most of you know, he possibly has not been in on any of your sessions before, but David has been prolific. He's a prolific speaker, analyst, and an author of several best-selling books on semantic search, SEO, and other things. He's written a book, in fact, on Hangouts as well, and he's been prolific in terms of his social media, sharing and even Hangouts, right from the very early days of Google Plus. So he's one of the guys who's possibly done a lot for this platform from the days when it was in beta, and that's when we got to know him. And David has spoken, I think, and has had HOAs on a whole lot of issues. Many of them. He's currently, I think, he's currently on vacation. Am I right, David, in saying that?
Yeah, kind of. I mean, I'm working on stuff, but yeah, I'm trying to take a break.
Okay. All right. But so, I was keen that if David could spare time, he joins us for this, and which is why very, very nice of him. Very kind of, I think, rescheduled, one or two things that he had, and he's in here today. So, saying that, I'll leave the discussions to you and David and anybody else who may have questions. I'm checking if there are any online questions through Q&A. I don't see any, but I guess there are questions on the first two cases that people would want to ask. So maybe we can pause at this stage and take those questions and then move on to the next case.
Hi, David. Thank you for joining the session.
You're welcome. I found it fascinating. You're quite right. We're acquiring more and more data at an exponentially increasing rate. The example you gave of the Rolls-Royce engines, for example, they actually generate, I think, a terabyte of information for every hour they're actually operational. So on a transatlantic flight, they generate an enormous amount of data. One of the greatest challenges that we face right now is actually the speed at which that data is processed and where it happens. And there's a transition from doing it from a centrally based hub, which has been a traditional model, to actually doing a lot of the processing on site and then generating additional insights, which then are tabulated in a hub in order to actually get the insights a little bit faster and create a greater structured approach to the information that's actually acquired. And suddenly, I think Airbus are in the process of implementing onboard processors, which will actually bring out insights on the data as it happens. But taking this to your example, are there sort of initiatives in place to use the current data which you have to generate profile signatures, if you like, which allow the identification of a bank client likely to churn within a specific time period right from the start, of their initial contact?
Yes. So you're right. I mean, I think there's a fair amount of work. I mean, that particular kind of work has been around for some time, and I think, I don't know why it's saying searching for a face. Maybe okay. I don't know. Raja, can you guys see me or?
Yes, we can see you fine.
See you.
So So that kind of searching for a specific, or basically identifying, what they call the acquisition, development, and retention kind of model has been around for quite some time. And I think most of the effort was essentially to try to identify the high-value customers, right? Because initially these costs of doing this was very expensive. You're right. They're kind for some time, and many banks, many of the larger banks, this has become pretty much standard kind of practice. Standard operating procedures identify folks who are likely to churn even before the or essentially give identification of churn even before these guys are actually even thinking about it. I mean, that there is essentially you're withdrawing your balance, your say you've stopped direct deposit, you've done all kinds of things. So yes, and I think that particular churn is also happening in the employee arena because as an employee you can also give signals that say that you're likely to leave the company. I mean, it's interesting. This particular aspect is called data exhaust. I don't know if you have heard the term, but
Yes, I do. Yeah.
I mean, when you folks, pardon?
I have, yeah.
You were saying something? Yeah, data exhaust.
Yeah.
I mean, it's interesting this how Google has turned this idea of data exhaust into a product. I mean, the history is that when the search engines were being developed 5, 10, 7 years ago, when you typed something which was a spelling mistake, Microsoft really didn't focus on that. They said, hey, it's a mistake, therefore we will not use that term. But Google basically started cataloging and creating a database of all kinds of errors and actually turned that into what they call the the autocorrect product, as well as for example, if you go into Google right now, type even if it's spelling mistake or it's something that you're thinking about, type something, they will come up with the right quote-unquote stuff that you're searching for. It's very uncanny, right? So that is what is called the data exhaust. So as we move around in this digitized world, whether we are going and buying something using a credit card, or we are filling up a gas station, or we're taking a flight, booking a ticket, we all emanate data at that stage, and each of all the data. But I think there is still an enormous amount of challenge in just trying to put this data together, store it, because it comes, as I said, the 4 V's. If you think about it, there is still an enormous amount of challenge, and there's a huge shortage of people. That's the other problem. Sense, guys, or I'm just rambling around? So.
Yeah. Well, Google are addressing this by actually applying algorithms in place rather than human operators.
Right. Yeah, exactly. So they're saying they're using machine learning to, but even a machine learning still needs to be thought through and implemented. I mean, one of the most difficult problems in robotics is something that we simply humans do intuitively. You want to look for a book, or you're searching for your coffee mug, your hand goes out and you grab the coffee mug and the book and you start reading it. In robotics, that's one of the most difficult problems, and they still have not been able to resolve it successfully. We humans still have an edge, thank God for that. Let's see how long that edge lasts, right?
Yeah. A lot of the data you actually referred to just now has to do with a identification of intent, and again, that's also takes machine learning and the processing of quite a large volume of data in order to determine the patterns which allow that to surface. But it is certainly doable.
It is certainly doable. It is certainly doable. I think companies are in the process of prioritizing where should they do it, right? And everything costs money, so let's target the most interesting problems, or let's target the most valuable problems. Let's target the most valuable customers, etc., etc. And as the costs go down, as the learning goes up, I think it will filter to whatever. I mean, you understand what I'm trying to say? So
yeah, absolutely. Yeah, and I think that's the right way to prioritize things, because it's the only way to actually see the direct benefits from that action, which would allow it to scale.
Right. I mean, if, for example, take aviation industry, they still are a little bit behind because, and I think it's a cost issue. I mean, aviation tracking equipment is there. All that technology is there. It's about $50,000 per aircraft to install tracking devices that will track and monitor on a real-time basis. And that's a cost issue, right? Unless the FAA kind of, because recently, the last 3-4 years, we've heard quite a few very tragic stories about aircrafts being lost. So, but as and when, I mean, I think, this is going to happen. It's going to this is going to happen. Nothing is going to stop it. I mean, the whole what I call the data onslaught is inevitable. Okay. So let me just walk you through the next slide.
Abhijit, I have a query about the first case that you mentioned. Maybe I missed it somewhere, or if you have mentioned it, but the first case. Is it possible to get the initial slide back on for that one?
Sure.
Okay. While you're doing that, my query was that it was basically what was the kind of the proposition or the concern area or the problem which led to this project and
well,
led to,
yeah. So that's a good question. I think I alluded to it very briefly. The concern area was the HR department wanted to make certain investments in human resources, right? But the board of that specific bank said, okay, you want to make, these are very unusual kind of things in training, in HR development, in all kinds of things. And for example, they wanted to come up with a create your own training program for each and every employee, right? So they would basically pick and choose various training programs that was consistent with their career goals and talk to their managers, etc., etc. So all these required various kinds of investments, and the board basically went back to HR and said, why are you doing this? Because we need to see some outcome variables or some outcome or some impact, I would say, on the bank profitability. So one of the ways that there were other initiatives too. So one of the ways this was being demonstrated to the board was there a link between customer satisfaction and commitment and employee satisfaction and commitment? Because, as I said, they are two disparate groups. Nobody really thinks of employee commitment being related to customer satisfaction. Of course, you would think it would be. It's logical. A happy employee essentially results in a satisfied customer, right? But by and large, there is no quote-unquote quantitative link, and the whole idea was to establish that link, even if it was at a soft level, I'm saying. Am I making sense here, guys? Are you following?
Yes. Yeah, absolutely. Yeah.
Yes, absolutely.
So, but the problem, as I said, was the unit of analysis. As David was saying, the Rolls-Royce engine and the aircraft is the unit of analysis there. It's not a human being, or it may be a machine or a physical asset. Here, the unit of analysis at one end was the employee, and at the other end was a customer, and there's no one-to-one match. Which is why there were, both customer satisfaction and employee satisfaction models at either end, but the linkage actually was at the branch level through kind of soft linkages. And I'll give you an example. This bank had a very large investment banking group, which are about 2,000 employees. And there, the customer satisfaction was not at the branch level. It was basically, just through, executive interviews with a few key customers, their banking clients, right? So anyway, am I making sense? So it's not always quantitative. There has to be a lot of, what should I say, executive interviews and qualitative research to kind of back up what you're doing, because we human beings like to also hear stories, right? Ultimately, the idea is to create a story.
Yes.
Right?
One question here.
Am I making sense here, guys, or?
Sure.
Yes.
You are.
The question is, was the relation both way, like satisfied employee resulted in more customer satisfaction and more customer satisfaction resulted in satisfied employee, or was it one way?
No, it's a good question, Shubhamoy. I think higher levels of employee, the basic idea was to demonstrate higher levels of employee commitment led to higher levels of customer satisfaction. However, there were, it's essentially a kind of a flat S-curve, if I may say so, but there were certain floor levels of commitment that were required to ensure a certain floor level of satisfaction. So we really didn't go the other way. I mean, the basic idea, but I think your question was, do higher levels of customer satisfaction result in higher levels of employee commitment, right? I think
That's
that,
right.
right?
That's right.
So we did not demonstrate that to a certain extent. The basic idea was to essentially, because see, the one thing about this customer satisfaction business is it's very hard to find, say, because each customer will have multiple accounts in other banks too, right? So we don't know what their entire share of wallet is. So that was the other piece, that, and typical most customers would divide whatever their banking kind of activities across various banks, right? So we didn't really go in the other direction as such. Am I making sense here, Shubhamay? Have I answered your question?
Yeah, I got that. Yes.
So in the time remaining,
Abhijit,
sorry.
Yeah, no,
Go
I'm
ahead.
saying if I understand you right, essentially you managed to establish a fairly strong correlation between, a satisfied employee and satisfied customers.
Right.
Did the project also involve finding some kind of a causation for this? So, I mean, certainly I guess the correlation was strong.
Good.
That you found that.
Good question. Good question. The causation was at a very qualitative level, Raja. I mean, even the correlation that I mentioned is also very qualitative, because, as I said, this was a soft linkages.
Right.
Essentially what we said that, for example, we established an increase in a certain percentage point in employee commitment resulted in so much additional branch activity. And as you can realize, this was actually had to be done across time. So it was like an observation period across time. So we couldn't manipulate and enforce an increase in employee commitment. What we did try to do was to basically divide the sample into kind of cells where there was low commitment versus high commitment across these two, say, different cells or regions of bank branches. Am I making sense?
Yeah.
Yes.
Because here you can't manipulate variables. I mean, it's very hard to manipulate variables in this situation. All you can do is kind of divide, and then there are other constraints, right? Because you're working with the bank this is not the most important part of their operations, right? They have to make money on a daily, ongoing basis. There are all kind of operational challenges. This was just one small aspect of what they were doing. So what I'm trying to say is we had to do this study and minimize disruption in operation and things like that.
Yeah, absolutely. I understand.
Okay.
Yeah.
Okay. Cool.
All right.
So let me just take you.
If I do not know if there are some other questions about this case or the second case that you took up. If there are, maybe you could answer them, and then we can go on to the next case that you have.
Sure. Any other questions, folks?
None from me. I think it looks pretty good.
Okay. Thanks. If I can only get my page down key to work. 1 second.
Okay. All right. So maybe we can move on to your next case.
Yeah, that's what I'm trying to do.
Yeah.
Okay. So here we're talking about the predictive analytics in the area of maintenance and preventive maintenance. So this is the kind of the maintenance maturity model. And I think I should preface this by saying that predictive analysis in the area of preventive maintenance it's a much more complex beast to handle, because there are all kinds of ecosystems and preventive the whole maintenance ecosystem that you have to take into account. So you have typically starting with reactive maintenance, preventative, then condition-based. So you have usage and wear characteristics, and you just basically you don't really have, sorry, that's a typo. Predictive models to predict failure is not, that shouldn't be there, but basically you don't really have predictive models. Then you have preventative. So essentially you have based on manufacturer's schedules, timer observations. Then you have some, condition-based is more or less maintenance monitoring, which means you based on some real-time or some delayed monitoring, you assess a condition of a machine and the assets, and then you take action. And predictive is actually the holy grail out here. There are some companies who are doing it. A lot of people haven't yet got there. But you try to develop predictive models to kind of predict failure. So what's the business value? I mean, if you say that you want to predict asset failure or extend life, and the business value is very clear. You determine failure based on usage, where characteristics you can estimate and extend component life. You can increase return on assets. You can identify conditions that lead to high failure. You can optimize maintenance. You can optimize your inventory. You can optimize your, say, work order challenges, resource schedules, manpower, etc., etc. So it's basically improves quality, reduces recalls. The business value for any kind of predictive asset optimization is enormous. You can compare the parts against the various master and see which one you need to reorder, which one you need to reduce stock, and conduct in-depth root analysis. So all kinds of things you can do. And most of this thing, at least on the left-hand side, is being done by nearly all companies that have very high, physical assets as such. So this is a case, and it's a very high-level case. So I'm only talking at a very high level. So where do we start? So the first thing, obviously, you start is collecting data. Where is the data? You start taking historical measurements. You start taking failure history. You start taking this qualitative research. You start talking to the folks on the shop floor. You start doing the analysis, the causes, the frequencies, the risk factor. Then you start classifying equipment. Then you develop your data. You kind of do some predictive models. You simulate. You score the data. You simulate it. Some of the outputs of that go into your, say, maintenance planning, and then that can help you derive a maintenance schedule. And even if you start monitoring the data, you can at least start developing your maintenance asset profiles, key performance indicators. You can start doing a mean time between failures, mean time between repairs, asset availability, downtime, component availability, stockouts, etc. And then you start creating a dashboard and report. So even though this one slide is very sweeping, what it does not take into account is the fact that a lot of these things happen across time, and there are only bits and pieces that happen across time. And some of those are still work in action, some of these are have already happened, some of them happened in the past, and they're trying to incorporate or improve it as we go along. The other interesting thing, since we're talking about predictive analytics, let's talk about some things that happen. So, on the green thing on the left-hand side talks about what are we doing? We're looking for patterns to predict, to kind of group and find outliers, to associate and sequence. That's where a lot of the machine learning algorithms work together. But even before you do a machine learning algorithm, you really have to create the data and prepare the data to kind of feed into these models, which is the toughest part. So if I were to say so, the left-hand side piece is actually the toughest part, is getting the data, doing the initial causes, frequencies, failure analysis, coming to an agreement with the management, with the business owners as to what to focus on. The other part about this whole predictive asset optimization is where I think a lot of software comes into play. A lot of software packages, software platforms. For example, you have to have an asset optimization software. You have to start thinking of, using something like business intelligence software. Like, you have lots of business intelligence software out there. So, like Oracle has something, IBM have their products. So, this is one area where the predictive analytics is one piece of it, but it is actually embedded in a very, very large software and hardware ecosystem. As opposed to, say, the bank employee commitment and satisfaction, where we basically collect the data, did the analysis, and presented results. One thing you realize as you're going into big data analytics, there is an enormous amount of software implementation and deployment that is required, which is actually another source of, what should I say, it's a difficult area to kind of, a lot of companies are still working on that to resolve the challenges there. Let's see. A minute here while I'm trying to.
Abhijit, just a question here, and at this stage, what was this vertical where this was done? I mean, what was the kind of industry where?
Yeah, I gave you a generic one. This actually, if I can get to my next slide, you'll understand it.
Okay.
But as you can see, the machines can be obstinate at times, and not letting me go down. Let me just do one thing. Raja, can you just keep everybody busy? Let me just do one thing here. I need to just do one thing.
Okay, or maybe you can. I mean, you just tell us. If the slide isn't coming on for some reason, it's okay. I guess maybe you can just tell us.
Well, this particular case was essentially in the mining business or mining industry, and this particular thing was basically with a company that had excavators, bulldozers, all kinds of mining equipment, and that was the basic idea. So the idea was to essentially get data on all their mining equipment on a global basis. I actually started with essentially in the U.S. and once they got the stuff in the U.S., they started implementing on a global basis. So let's see if I can do this.
So if I assume right, you're trying to take us on to what the final results and outcome is.
Right. That's what I was trying to do out here, and for some reason it's not happening. But let me see if I can do it. Wide stream the Dell webcam central. Sorry. Right. So can you see the screen now?
Yes.
Yeah. Yeah.
Sorry. So yeah. So this is mining equipment health monitoring. So it was one of the largest contract miners, and for example, they mined everything, right? Coal, iron ore, copper, gold, uranium. And one of the things was to, first of all, they have to develop the data capture, modeling, and analytics. It's a very high-level thing. So, and component failure predictions and use options, and then improve the whole maintenance management, increase productivity, and then unify these maintenance and mining production management. So this was an ongoing thing. It's still going on. Right now, initially started doing of monitoring activities as opposed to going to the predictive analytics. So the basic idea was initially just trying to monitor at component by component level the failure rates, etc. So that was my case on. I mean, I have other cases, and some of these cases are still. And I can't share all the details with them with you guys, but this was the best one I could think of, which was kind of.
That's fine. Yeah, that's all right. From how long has this been on? You mentioned it's an ongoing thing and it's still going on. So.
Well, this particular project started in 2011 or so, 2011 or 12, And the initial emphasis was really mostly on just monitoring. The initial emphasis was just getting the data and identifying the equipment. As you can see, the kind of, if you take a bulldozer or any kind of an excavator, the idea was to identify what are the critical components and the most expensive components that need replacement, right? Which can essentially, I mean, even with something not working properly, they can still work. So the whole process was taking, say, so let's say they have 10, 100 types of equipment, and there are 10 of these which are really the most expensive and valuable. Out of these 10, there are 100 different parts that are the most important and valuable and most difficult to replace, both in terms of cost of the part as well as downtime and the human resources required to replace the part. So that was the kind of, what should I say, the waterfall activities that we had to go through to kind of, okay, think of these 100 parts for this particular equipment, and then how do we get the data for that, right? Am I making sense here, guys? So as I was saying in the previous slide, we saw that left-hand side, which was the failure analysis, historical data, and then they actually, a lot of these things didn't have any sensors at that point in time, so they had to install sensors, connect them to their network, and start getting data. Initially, obviously, it was a lot of garbage data that was coming in. They had to fine-tune those sensors. So anyway, the basic idea, as you can see, is that it was fairly a difficult, involved exercise. Am I making sense?
Yeah. Okay. Just not a very direct question about this case, but a related one is, for example, when you started on this in 2011, as you said, did this organization have already a setup in terms of their own data scientists and analytics and even some of the algorithms that were used? Had they already developed all this, or it had to be all done from scratch?
No, they were basically in the process of also developing. They had an analytical group, which was obviously but they were also learning along with us. So one of the mandates was to also kind of train the folks as we went along to kind of start using these, start basically, how do we capture the data? How do we start using the data? How do we store it? So there's a lot of other hardware issues involved, and everything was done on a phased basis, as you can see, because each of these had to be funded from the board level, and the funding had to be organized in such a way that there was justification. Say, okay, if we fund this, this is the kind of productive measures that will happen, and then we have to do this on a POC basis, right? So there was a lot of POCs going on, proof of concept, and some of the POCs did well, some were kind of turned down, and so forth and so on. At the same time, as we were doing this, the organization was also learning and hiring people. Am I making sense, Raja? Have I answered your question?
Yeah, yeah. Just
so many
question. Sorry. Yeah.
All I was saying is many of these things that happen, we see, like I look at the example of if you ever built a house, you don't see the mess that was around. At the end of the day, end of say 1 year, your wife comes in and says, "What a lovely house!" Everybody says, "Nice house," but nobody has seen the mess that was around and all the difficulties, etc., that you had to do to build that house, right? So what you're seeing is a final slide that shows things, but the pain and the anguish and the agony you went through, the whole process, is not normal, right?
I can imagine.
Yeah.
And like again, maybe just taking this particular case, but I guess it will be true of some of the other cases as well. What percentage of the total effort or time was spent in kind of identifying or researching the right data sets to get, cleaning up those data sets, refining it, getting it into processable form, stuff like that? I mean, roughly what amount of the total effort was spent on that?
That's a very good question. I think about 70 to 80% of time, that's my standard, is usually spent in just getting data sets organized, even before data sets, getting the management to buy in and prioritize, areas to focus on. So about 70-80% doing that.
Oh, okay.
Yeah,
It's a significant
that's fairly.
investment.
Yeah, it's fairly standard as well. Unfortunately, you're quite right.
Right.
But for this project, what I understand is there were some engineering changes also. I mean, you installed sensors and all, and
Yes.
you said that.
So right, right. I mean, they had sensors, but nobody. I mean, the thing is, a lot of these equipment have built-in sensors, but they're not connected, right? So you get that what I'm saying. Many we buy. I mean, you look at your Microsoft Excel. I mean, there are so many advanced features in Excel that we hardly use, right? So that goes true for all kinds of equipment that are basically are around, right? So I'm just giving an example, but a lot of the stuff had stuff already built in. They had to be activated. They had to be connected. They had to be whole slew of activities around that.
So that
Have
way
I
it
answered
was.
your question?
Yeah, I mean, that way it was not only a software project; it was more of a software plus engineering project.
Yes, 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 yes. Which is why right at the beginning I said that this whole idea of preventive maintenance is really, really a lot bigger ecosystem around it, which I haven't talked about in this. I don't have a slide, but there's a big around whole idea of any kind of asset optimization or any kind of factory monitoring. I mean, a lot of the activities are also going on, for example, in say automobile manufacturing, right? I mean, one thing you'll notice that the price of cars for the last 20 years have been pretty much static. And the reason for that is the enormous amount of productivity that has happened in the automobile business, as well as pressures on capacity, etc. But I attribute a lot of that to productivity increases in factories and shops worldwide.
Abhijit,
So I think that's what I have, Raja. I mean, I don't know if there are any more questions, but you can.
yeah, I have one last one from my side, and then I'll leave it to the others if they have. Uh, could you just give us an estimate from start till now, or till the last period that you approximately what has been the outlay or what has been the investment on this particular project so far? A very rough idea, maybe.
Outlay of what? Of the
I
costs?
mean total investment on this. I mean,
Yeah, I
appro-
don't, very frankly, I don't know that number, Raja. I don't know that number. But one thing I can tell you is the costs have been going down. I'm the bank project we did, that was Raja. It was no, it was I think in the range of $750,000 project, right? And that was say 10 years ago. Now, if you that kind of project right now, it would be impossible to find the funding, right? Because the cost of a lot of those stuff has gone down. So the costs actually vary depending on um, the intellectual, what should I say, whether it's whether it's something that is commonplace or intellectually available as such off the shelf, or it's something that is new. Because there's always a price to pay for being the first on the block, right?
yeah.
So I mean, if I were to say answer your question, I mean, some of these projects typically have run into the neighborhood of 10 to $100 million, because um, there is a lot of hardware also installation involved. This is just so the predictive analytics is a very small piece of it, right? And the predictive analytics piece is not. It's more human resources, the data scientists, the data folks, and the predictive analytics folks. But the hardware and software kind of overwhelms. I mean, I think it's about 95% to 90% of the project costs. But for me to give you an estimate, but POCs or proof of concepts at right now run in the neighborhood of anything from $100 to $500,000. Just as concept, nothing else. So for example, if say I have this and later data, and I just want you to come in and just look at it and tell me what is there any value in the data? What do I do with the data? Can I start implementing other stuff with the data? That itself is anything from a, it's like a at least $100,000 project. This proof of concept. $1,000, mind you. So don't get ideas. There are lots and lots of people in the pool who are going to make that money, right? So piece in this whole puzzle. Have I answered your question?
Yeah, you have. I think that's a fair overview of what it takes to do a project like this.
Yeah, the cost of actually all this is going down as we speak. It's going down. I mean, yeah, because as David was alluding to it, there's efforts to reduce costs by doing a lot of machine learning. So now there is machine learning to do machine learning, right? It's it goes beyond that. So
right.
there are a lot of efforts to reduce costs, and unless the costs go down, a lot of these things will not be implemented.
I leave it to the others. David, in fact, does a lot of has a lot of consulting experience as well as speaking assignments, corporate trainings and so on. So, I mean, I leave it to David to maybe add any insights of his that you'd like to.
Well, I think Anambijit identified this very well. The greatest investment in time in actually making these things happen is actually explaining the benefits involved to the management structure so they can actually make the right decision. In any organization, there's still quite a high level of resistance to any kind of change because they don't always understand the benefits which are projected from it, but also because any kind of implementation like this inevitably at some point will facilitate and elicit organizational structure change. And a lot of organizations resist that for obvious reasons. So I think one of the reasons we don't see a very wide uptake across the industry to this kind of thing is precisely because organizations, as they're set up internally at the moment, are not really geared up to deal with it. And the organizational restructuring involved involves a very heavy human element. We get careers and egos and department heads and department territories which are going to be affected. So there's always that build-up of resistance within any kind of organization. So I find it fascinating that so much time goes into it, but it's also the reality that I see in pretty much anything that has to do with any kind of change at this kind of level.
Yeah, that's what we found too. Exactly.
Yeah, exactly. Any queries, David, about whatever Abhijit was talking about in the last case?
No, I think he did a marvelous job in describing the complexity of the subject, and certainly helped having the slides there. It's very much a growing field. The fact that we can actually have machine learning to aid machine learning, and Google has made huge inroads in that, is actually quite indicative of the level of acceleration which we're going to see in this area in the near future. And what it means essentially is that the threshold barriers in terms of cost are constantly going down. So we're going to get higher levels of precision, more and more practicalities emerging out of this, greater levels of practical abstraction, inferences, if you like, at a lower cost. So at some point, it's going to be adopted across the board in pretty much every organization. I mean, right now, IBM are busy opening up Watson through an API interface to developers who then take that computing power and apply it pretty much to anything. And this is just one case. So we're going to see more of it.
Right.
Pretty sure of that. Okay.
Subhamoy, any queries? Any other queries that you may have?
No, I don't have any.
Okay. So I guess that more or less wraps up this session, and thanks everyone for taking the time out to kind of do this. And at least personally for me, I think it's been very informative, and I suppose it's given me and several other people fair amount of insights into what it takes to do projects like this and what the possible outcomes are, and what the infrastructure and the resources and the processes that one has to go through. So saying that, thanks once again to everyone, and we'll conclude this session here. Take care.
Thank you very
Bye.
much. Nice seeing everybody.
Bye.
Take care. Bye-bye.
Take care. Bye.
Thank you.